So hi everyone, I'm Emily Lakdawalla from the Planetary Society here with the weekly CosmoQuest Space Hangout. Thank you all for joining us. If you're watching via Google, please +1 or do a thumbs up on YouTube in order to indicate that you're watching. We love to know how many people are watching live. Joining me today is my guest Britney Schmidt, what I've been calling you a planetary astronomer from the University of Texas at Austin. And I thought that we would just start by maybe talking a little bit about what kind of work you're doing right now, because I know that you're only recently moved into this professional position there, and I know that as a grad student you sometimes do other people's projects a lot more than your own, and so I know your work may be kind of shifting a little bit at this point.
Yeah, actually it's kind of a funny story. I ended up at Texas because I've always wanted to work on Europa, but when I was entering grad school, there was nobody really hiring grad students to do that for the most part, and so I focused on another interest of mine that was kind of the history of water in the solar system, which led me to the asteroid belt, and so I was a grad student working on the Dawn mission there. So while my, shall we say, skill set and focus is rather broad, I'm finally getting to work on what I really wanted to do from basically when I decided that planetary science was right for me in undergrad. So it's really nice to be getting a chance to do that.
So tell us about what you really wanted to do.
Well, I can remember sitting in class and thinking, hearing descriptions of all the planets, and I'd always kind of been an astronomy buff as a kid, and then I didn't really know much about the moons, and so it's one of those things where you learn in school, you learn the 9 planets, and you learn, stars and galaxies and everything like that, but you don't really think about the individual planets and their systems. It's something that education is doing now, I think, a lot better. But so the first time I really heard about Europa was actually in college, and I wasn't actually a science major at the time. I was kind of a little bit of a confused writer, you might say. Really looking at, maybe trying to focus on those types of things, the written word. But Europa, hearing about an alien ocean under an ice shell. I mean, there's nothing more, at least to me, provocative than that in terms of the search for life beyond our own planet. And so that's why I wanted to do this. It was really what convinced me that, all right, time to get a physics major, time to really put the pedal to the metal and see what I can't do to contribute to this field, so that maybe by the end of my lifetime we'll actually know whether there's life out there on Europa. And so that kind of interest in water in the solar system has driven me there. So that's pretty much why I got really excited about it, and why I continue to work on Europa specifically.
And is it just Europa? Do you find Ganymede interesting as well? I mean, it's got its own magnetic field in an ocean down there as well, right?
Yeah, one of the problems with the solar system is there's so many interesting places. I mean, it's a blessing and a curse, as they say. Ganymede's certainly an interesting place. What I think is amazing about Ganymede, I mean, not only that it's the only moon that has its own magnetic field. I mean, there are planets that don't have any magnetic fields anymore. Mars, Venus. So the fact that that Ganymede, a little moon of Jupiter, has its own is pretty amazing. But that it's made mostly of ice, that it has this kind of water sandwich interior. I mean, that's amazing. So it turns out, for those who may not be aware, Ganymede is kind of in this situation where it's so big that the pressure inside Ganymede starts to affect the stability of water and water ice. And so basically Ganymede, you can think of it as a water sandwich. There's an ice layer up on top, and an ice layer on bottom, in the water in between, and then underneath that bottom layer is where bottom ice layer is where the silicate interior is. So it's really kind of an interesting place in terms of really pushing potentially our understandings of what really is habitable. Interesting geology, I mean, amazing place as well. So the whole Jovian system is kind of like that.
Yeah, it's a pretty awesome place, and it's kind of sad that the United States has had a little bit of a trouble motivating to get back there after and follow up on Galileo.
Yeah. Yeah, I agree. I've been part of the move to try to get us back there, back to the Jovian system, back to the AC satellites there, because yeah, I mean, we found some of the most exciting results ever with Galileo when the magnetometer detected the presence of an induced magnetic field that told us Europa and Ganymede and Callisto each had an ocean.
Callisto
Amazing
too?
result. Yeah, Callisto
Oh, I
too.
didn't realize that.
Yeah, Callisto has the same signature. Callisto's kind of a weird one, of course, because it's not completely differentiated, but turns out right underneath that ice layer is probably at least a fair bit of water as well. It's just an amazing place, and it's funny that we talk about how long it's taken us to go back, because pretty much immediately afterwards, NASA started studying missions to go to Europa specifically, and to tour the Jovian system as it went. And they just didn't end up going through, which was really pretty unfortunate, if you ask me. I mean, that was as early as 1999, 2000, were the first solid proposals that went in to try to get these missions going forward. So just a real bummer that it didn't happen then, because where would we be now? But we still do have a mission on the table, which is why I'm really excited. And I mean, the most amazing result ever, right, is that last week, or I guess last week, they selected JUICE. The Europeans selected their Ganymede mission, and I'm thrilled about that because, oh my gosh, it was earlier this week. Anyways, I'm just so excited about it because the implications are that we can go back to the Jovian system, and there are 2 flybys of Europa. So, and they're 2 important flybys. You can do a lot for our understanding of Europa just with that little bit. So I'm really jazzed. The great thing about the JUICE mission is that it actually studies the entire system. It's not just one moon focus. They're going to do a really great job of work at Ganymede. It's a great place to orbit. It dominates the system, aside from Jupiter, obviously. But what they're going to get is they're going to get the plasma and magnetic field interactions, which is really cool because the Ganymede-Jupiter interaction is kind of a microcosm of planetary interactions with the sun's magnetosphere. So we're going to learn an incredible amount about magnetic environments there, get some information by looking at Europa and Callisto and Io from a distance, some targeted flybys of at least Callisto and Europa, but we'll get a great picture of how icy satellites and even Io work, and then how that entire system is put together. So I can only hope that the U.S. decides to, jump on board and help us, get some instruments on that spacecraft, but also choose to do the Europa mission as planned. It'd be amazing because having 2 spacecraft there at the same time to do complementary science, I don't know, nothing beats that, I think.
That would be pretty awesome. And I noticed you have been saying "we" a lot. I'm curious to know what that "we" actually is in your mind.
Yeah, we, to me, I think really is us as a human race for the most part. I mean, maybe that's a little bit romantic, but that tends to be the way I feel about it. But it also means the scientific community. There's these missions, even though they're, the instruments are run by a few people, there's hundreds of scientists that have put in support and data analysis and work, and teams of scientists that led the study teams. And I was fortunate enough to be able to participate in that, not really as a study team member, I was too young at the time, but to be able to help out with some of the planning, and that was a great experience for me. So that's just an example of how many people, even those who aren't really the focus of the study teams, really get involved. And so the "we" is kind of everyone. And the types of questions that we're asking with missions like this, I think, are the kinds of things that unite us as people, not just as scientists. I mean, I could bore the universe to death with how excited I am about phase transitions in ice and how ice works, and this feature and that geology versus the other. But I mean, the question of are we alone in our own solar system, I think, is well beyond just the scientific community. So that's what it means to me, at least.
Yeah, I think there you'd find a lot of agreement with people in the plant, particularly my boss, Bill Nye, who always, whenever he gets a chance to speak to anybody about space exploration, he says the goal is to answer the very most important questions, which are how do we get here and are we alone?
Yep.
And I found when he said that at NASA Night at LPSC recently, I felt like not there was a large proportion of the audience that weren't actually with him on that. And clearly you are. Clearly it motivates you. I'm wondering how you feel, what you think. Do you think I was right about that? You know?
No, actually, I don't. I think that everyone really is there with you. I think LPSC was an image of frustration. There was a lot of frustration in that room, and the year before that was the year when the Europa mission that we were certain was about to be selected, got really horrific news, and so the outer planets community was just devastated at that one. And what was funny was that this year we were, still feeling about the same way, but we'd gotten used to it. It's one of those, like, you go through the stages of mourning, but for most of the community, that was the first time they'd been handed that kind of news that, oh, by the way, your favorite project and funding for this major portion of what you're working on doesn't work. And so a community that's become a minority because of, less funding, the Outer Planets group, for the most part, has kind of dwindled in numbers at these meetings, and so it's maybe not as obvious as when Mars takes a hit, but it's still important. So I think probably what you were seeing there was just people being a little frustrated and a little bit, not really in the mood to celebrate the lighter side of things and really looking for answers. So
Yeah.
I know how scientists work, man. They can, it's good to do things like this because it takes you out of the daily grind and the details and the politics and whatever, and reminds you of why it is that you did this in the first place. But I doubt that anyone got involved in planetary science because they really wanted to figure out how dust scatters in X environment under whatever gravitation, right? It ends up being something they're really super interested in, but it's a piece of a bigger puzzle, and I think everyone probably knows that.
That's awesome. I want to pause for a second for station identification. And I'm Emily Lakdawalla from the Planetary Society. We're here with the weekly space hangout, weekly science hangout on CosmoQuest, and my guest today is Britney Schmidt from the University of Texas at Austin, who has finally achieved her life's dream of studying Europa professionally. So congratulations to you on that, Britney. We've been talking about the moons of Jupiter. You did mention the fact that you worked on Dawn, so I'm wondering what can you tell us about life inside an active mission? Even though you're not an asteroid person per se, what was it like to see the approach to that world for the first time?
Yeah, I guess at this point in time, I'm just kind of a solar system person. I tell people that I like everything past the orbit of Mars, but that's not true either, because I've, Mars topics I work on and worked on a Venus concept, and, so, but anyways, missions are pretty incredible. And I was fortunate enough to come on board the Dawn mission as a graduate student before we even got there. So I've actually gotten to, as I tell people, kind of grow up with the mission. I was there when it launched, and it was early in my graduate career in 2007. And so I'd only been a grad student for 2 years, and I'd been helping get the mission planned and seeing how that all worked, helping to plan observations, helping to kind of decide how things were going, and at least getting to watch that process. And then seeing it launch and then being with it as it was traveling was really pretty awesome. And then when I graduated, because of some, basically the way deadlines worked out, it wasn't possible for me to apply to be on the science team directly. But what was great was that I was planning on focusing on Europa anyway. Didn't think I was going to have a ton of time to be doing a whole lot of science outside of that. I mean, at the time we thought we were going to have a mission in a year. But what ended up happening was the Dawn Education and Public Outreach team needed a scientist to help them basically craft the education portfolio and how science gets translated to the public, and that's something I'm really interested in. And so I applied for that position and was awarded that, and so that's been my involvement, is that I haven't really been working with the data myself, but I've been in the team meetings and trying to translate the excitement and the process that the team goes through, and you get to see the whole science team go from observation planning, wondering what it's going to be like, testing out the instruments. You know, you have spacecraft safings, you have instrument anomalies, things that are totally normal. They happen on every single mission, but every time it happens, it's kind of a new thing. And so seeing that process has been pretty amazing. And then when you finally get there, I mean, I can't even tell you how exciting it was to get those first few images, even when Vesta was like a little tiny dot. You know, it was so thrilling to people. And then when we actually got into orbit, it was really pretty cool. And it was funny because we had these two different orbits. So we kind of came in, and then we had survey orbit. And in survey orbit, Vesta looked really interesting, you know, different colors, and you could see some impact craters. You could see Rhea Silvia, which is the giant South Polar mountain. So people were thrilled. But it was amazing was the difference when we went from survey to Whammo, and all of a sudden those fractures jumped out at you.
I should jump in and say that Whammo is the high altitude mapping orbit.
Yeah.
It's funny, you know, we're 20 minutes into it. That's the first time I've had to stop you to define an acronym. And usually with most people it's much earlier than that. So
well, you can tell I got excited about it. So so for me, I mean, that was my like aha moment. So it turns out that when I was in grad school, the last chapter of my thesis, I actually wrote about impact events into Vesta, basically flipping it over, and depending on how warm it was, being able to affect and create tectonics on the surface. So I got really excited about that. And then in the first set of images, it really didn't look like Vesta had any tectonics at all from survey, and I was kind of bummed. But, you know, you write these kind of predictions, and you do the science. It was a great, you know, I learned things. We learned things about the physics that we hadn't known before. But then when we got into survey, or into the Whammo, the high-altitude mapping orbit, to see those fractures, I mean, even if I'm not right about how they formed, man, that was the best single image I've ever seen. So, you know, it's funny because I've heard scientists who are really established remember like the first image that they got back from the surface of, from the surface of a planet, or the first time they saw something up close. And when I was in undergrad, I was at an event where they released the first images of the surface of Titan, and that was amazing. And I remember being really emotional and thinking that was an incredible thing. But to like see that first snapshot of something you worked on and thought might be there to just show up on the big screen in the Dawn Science Team meeting was, oh man, I can't even describe how great that feeling was. So, that's the kind of roller coaster that you go on. And then, as the mission goes from planning and from kind of getting ready for the science, and then now it's to the point where all the science is being written up, but they're just starting to figure things out and just starting to write the first results and
in fact,
starting to debate all of that.
The first science papers are coming out tomorrow. So look, everyone who's watching this, check out the news, your favorite space websites. I won't get to the news tomorrow because I'll be busy in Baker, California, watching some rover drivers drive a model of Curiosity around some sand dunes, which will be kind of awesome. But I'm going to miss the Vesta press briefing, so I'll have to catch up on that on Friday.
Yeah.
But check it out. The first science is coming out shortly.
I think it's 2 p.m. Eastern, I think, is the live. NASA's going to do just a panel discussion of the papers that are out in Science this week. So it's very exciting. It's really cool to have been through this whole ride with it, all the way back to the fact that in the first year that I was on Dawn, my first year of grad school, was the year that they canceled the mission. And so I've been through every emotion with that mission, So it is really pretty. It's an amazing experience, even outside of the science.
Now, you and I both communicate a lot about science to the public. We do what we can, but clearly, I think one of the reasons why NASA is not getting the money that it needs to pursue the missions that we want to do is that I think there's been a failure to communicate to the public and to a wide enough segment of the public what's going on right now, why it's important, why we're doing what we're doing. And I wonder if you have any ideas about what the community should do, both enthusiasts and professionals, to try to get the word out a little bit better.
Yeah, so I have a lot of opinions on that. It's actually something that's very important to me. I've been getting active by writing and meeting with, members of our House of Representatives, going through the different pathways within the planetary science industry, through the Division of Planetary Sciences, through the American Astronomical Society, American Geophysical Union. So those are all the things that we do as scientists to kind of tell ourselves and tell the powers that be what's going on. Something that I think gets dropped in that is exactly what you're saying, is the communication to the public. And so what I've been trying to do, actually, especially because it became really important this year, because we saw everybody's having a rough time, and it's a question of priorities and a question of results and benefits. And I think because we get so excited about our own details, we tend not to turn outward and tell everyone else what they're really getting for the money that's spent on spacecraft and planetary science specifically. One of the things that's really interesting is that if you think about the cost of a mission, it seems really huge. If we say, okay, this Europa mission is a $2 billion mission, or the Mars mission is a $4 billion mission, or it's $30 billion over 30 years. It sounds like a huge amount of money. Compared to what we actually spend, it's nothing in terms of like national spending. It's huge to you and I, and it's so small compared to what is generally being spent. But more importantly, what that's doing is it's paying the best and the brightest, the smartest people in the United States to do their jobs and do them here, and do them well. I might mention that most of those people are not working at what they would be paid if they went into private industry, myself included. Man, I have student loans out the wazoo, my car is constantly breaking, I live in an apartment, and I have a PhD. Like, that's just crazy, right? Like, most people that I know that have bachelor's degrees own a house and a family and a nice new car, and I've got a PhD and I'm paycheck to paycheck, and still trying to make ends meet, and it's just the way it goes. But in terms of what we can do, I think humanizing science is an important part of it, and I think being open to doing things like this is really important. There are interested people out there, and they deserve to know what's going on. And it's not just, hey, look at this picture of something cool. For me, because I'm really glad that I got to be involved in the education and public outreach part of the mission, because for me, I really want to help people understand that science is a process. It's not a destination. It's not a single picture. It's not, where are the pictures, and why isn't it closer up, and why can't I see this? It's how the science gets done that's different. There's a decade of planning or more before that mission goes. Dawn was proposed for the first time in 1994. That's an incredible amount of time before you actually get to see the results. And the results aren't the picture. The results is the understanding. And so helping people see what I see in images and see what I see in data and understand the process of going from a planning and testing a hypothesis to testing a hypothesis, I think is something that I'm trying to do. And I hope that more scientists will try to do that. And so to me, I think it's humanizing it and making it transparent, but also remembering to go out and share with people why you're excited about what you do. And I think that that's actually coming across a lot more. A specific thing that I've been doing with a group of friends of mine, we started a meeting just after the decadal survey came out last year. The decadal survey, by the way, is the way that planetary scientists kind of get together over a couple of years and decide what the future of planetary science might be, what the priorities are. And so what we did, and by a group, I mean a group of really young scientists, what we realized was that people in the room have been chosen because they've got a long track record of experience, they've worked on a lot of missions, they have good rapport with the community, and they're chosen to help make those decisions. But that there was this window where the people that were coming up, the most prevalent numbers, the people that are postdocs and graduate students who are just about to start applying for funding and needing jobs and things like that, but those people didn't actually have, they had a voice, but they weren't necessarily using it or didn't know how. And so what we've done is we started an just kind of a group where we were meeting, at a bar in Los Angeles every time I was actually in LA from Texas. And we'd have a meeting and we'd talk about how to get young scientists involved, talk about what we wanted to do as a group, got a mission statement together, and then we started having meetings at LPSC this year, and we started a Facebook group, which has just blown up in terms of use by the community. It's a place for people to go and talk about these funding issues and how we can do better, going on congressional visits, things like that. And what's great about it is it's open membership. And so, in fact, anyone who's interested can go and watch that. And so I think that transparency is really important and might actually help us. And we're trying to improve fundings for young people to get involved in the process. So hopefully that ends up happening. But it's just one of those things that, unfortunately, it's hard. It's so easy to sit in your office and work on a paper, and it requires you to kind of commit some extra time. But I think that those are the ways to make science transparent and really give back to the community that gives so much to it. So I hope that these types of things are effective.
I'm wondering, it also occurred to me to wonder at that meeting if when scientists do their outreach, they tend to focus on the particular little piece of science that they do. And I'm wondering, because space exploration, it is a uniquely expensive kind of scientific research that's done. So I think it's important to justify the whole enterprise, not just we need a Europa mission, but we need planetary exploration. And I'm wondering if you agree with that, if you think there's enough of people doing that, or if we could improve.
Yeah. No, I totally agree. I agree with supporting the entire community and making it possible for people to really do really good work. In my experience, it's best if those come with specific examples of what you can do with it, because otherwise you get the flying car question. Where's my flying car? Well, if you were to project forward the budget for the lunar program, for the Apollo program, then maybe we would have that kind of a flying car by now. But we're certainly a lot closer to it because of NASA and because of all of the programs. And I think in terms of general benefit to society, specific questions are really great because they satisfy human curiosity. They teach us little pieces of exactly those things: who we are, how we got here, where we're going. But I think that the entire enterprise is where you get, you're exciting people also. Something that I like to focus on is that when I was a kid, I didn't go to school because I desperately wanted to be an accountant. It's not that that's not important. It's totally important. But, there's something that NASA has, that inspiration factor, that is just incredibly powerful. And remembering that and keeping that involved in the process of science and the process of promoting it and the process of communicating it, I think is really important. And it's something that kind of doesn't get talked about a lot. I really like conferences where they've got scientists up on the stage that are all wiggly and giggly about what's going on. And, when you see a launch or you see a landing or something, you can actually feel that excitement. But I think that showing the context for that's really important, because it is the whole process. There's a bunch of engineers in there that'll never really see an image from any of those spacecraft, but they learned something about how to make a mechanized system work. They learned something about autonomy, and all of that ends up going back into the public knowledge. And so I think it's something like, for every $1 spent on the Apollo program, about $7 of private corporations, or $7 was made by basically private and public corporations after that, using discoveries made during the Apollo program. And that's not unique to Apollo. It's the same for the shuttle program. It's the same for every mission. We learn about radiation techniques. We learn about miniaturization of energy sources and computer systems. The camera phones that are in our, the cameras that are in our phones these days are derived from astronomers, going from photo plates to CCDs. The CCD in our camera phone came from astronomy. It came from planetary science. So I don't think that there's anyone out there, well, there's probably several people, but there are very few people out there that don't have a CCD camera somewhere in their life. And so that's just an example of how important it is. And it might be silly. Maybe we could get along without a CCD camera, but I certainly like, posting pictures on Facebook and stuff. So I think in terms of, life enrichment and contribution, it is the whole package that's important.
I'm wondering, you're kind of a leader in this group of young planetary scientists. I'm wondering if you think how you think the culture is changing from the people who are currently, the senior members of the community, and how things are shifting over time. You do spend a lot of time working with other young scientists, people in their 30s and even 20s. So what's changing?
Well, I mean, to be honest, I think that the face is changing and how we do science is changing. As the questions get bigger and more complicated, it requires more people. One of the things that's interesting about planetary a program in colleges. Astronomy always has been, it's been for, hundreds and thousands of years, a focus of humanity, but planetary science specifically hasn't always. It's a natural progression, I think. But so that type of a community is really what's become very different. There's a lot of what we call soft money positions. There's a lot of people working on smaller amounts of grant money in different places across the country, rather than at a university or a research institution or a NASA center. And so that's something that's changing for sure. In terms of young people, because of that, it's easier for young people to get involved at some level, but it's also kind of the double-edged sword that it's also very difficult because your ability to
Have we lost you?
Oh, sorry. Oh, there we go. Are we back?
Your signal's getting a little worse now, so.
Okay. Well, we're hopefully be able to fix that. So, yeah. So I think what's changing, hopefully, is going to be the involvement at all levels. One of the reasons that I think that the funding has become what it is because people got passive. Flagship missions, there's been a lot of talk about how small class missions support lots of people. They do and they don't. They support more ideas. They're smaller scale ideas, but they support a much smaller number of people. They do support more engineering, but they mostly support more launch vehicles. And so what's actually happening is that the big, huge flagship programs that ruled NASA in the 70s and 80s and 90s, those are where most people were supported as grad students and as postdocs, and that was their way of working into the field. The RNA program has also always been important, but that was the kind of way that you got your feet wet. As those missions start to die off, and these are rapid-fire, very quick, short lifetime missions, it's really going to change. And that hasn't really been discussed very publicly because, scientists want to get their ideas across, and if your idea is for a small-scale mission, well, then it seems like, well, I got to PI this mission, this is something new and different that never would have happened without them. The problem is we really do need both. We don't need just one mission that takes up the entire budget, but we do need large missions that are long-term stable so that people can grow into the field. And so what I'm seeing a lot of is that the number and the appearance of the faces, there's a lot more young women, there's a lot more young people in general, there's a lot of bigger conferences with more and more students. But one of the things that seems to be lagging is those people getting permanent jobs. And so that's the kind of thing that I'm hoping this kind of grassroots advocacy that I'm actually seeing pop up in more than just planetary science. Astrobiology is doing the same thing. That kind of grassroots level will maybe help filter that down and develop the kind of stability that it takes to really train and keep going an entire generation of innovators. Hopefully that's what continues to happen.
Yeah, it's a big worry because after 2017, when Cassini's going to plunge into Saturn, there's no way to extend Cassini any further. We'll have Juno at Jupiter, but Juno's lifetime is going to be very short because it's traveling close enough to Jupiter to be frequently fried by its magnetic field. And again, there's no way of extending that mission either. So after 2017, no matter if the United States started a mission today, there would still be a several-year gap between outer planet missions.
Yeah.
And I'm kind of not counting New Horizons because their their flyby period is relatively brief, and then they're quiet for a long time again. So really, in terms of the big missions, that's it. And there's going to be this gap, and I'm wondering what everybody's going to do for those few years, even if they manage to get on Juice later.
Yeah, I think it's a really big question. One of the hard things to realize. I mean, there's a lot of interest in missions, but one of the things is that there's an incredible amount of data, particularly in the Mars program, that hasn't even been looked at really. Maybe it's been looked at, but it wasn't like the flashiest picture that anyone ever saw, and so it hasn't been worked on. One of the great things about being a little bit data starved is that you get creative and you get innovative and you learn new things and you try to push the envelope on what you're doing with relatively limited resources. But it's hard to feed a community that way. So my hope would be that we balance exploration a bit, and that I think would actually be great for the Mars program. I can't imagine why not. There's an incredible amount of data that isn't even looked at, and allowing that understanding to be what's fueling, RNA programs and things like that, that's going to help out young scientists for sure as the next kind of classes of missions are being built. But it shouldn't just be frequency. It's also the quality and of the data, but also the quality of the analysis, the time that you have to analyze it. So I'm hoping that we can get some new starts around here for various programs. The idea that New Frontiers and Discovery might be slowed down to make way for another mission that wasn't in the decadal survey is something that really bothers a lot of people in the community. Because those missions, we realize they're not flagship missions, but they're a step. They're a step in their use and learn how to work on is basically certain frequencies of radar. Ice is transparent, and so you can basically have your radar detector going all the way along, and these waves penetrate down and they'll bounce off of water. So you can actually map out water inside the ice shell. So you get a whole new dimension of Europa. So we'll be able to look inside the ice shell for water bodies and for how this geology really happens. What's very exciting is that if certain areas of the surface are cold enough, the radar may actually penetrate all the way to the ocean, which would be really exciting. So in a couple of flybys, we'll know tons of things. We may not know the ice shell thickness at the end, but we may, and we'll certainly be able to go looking for subsurface water. So it's really kind of an exciting time, at least. Nice to be actually selected to go do something.
So we're almost through the hour that we usually allot for this, and I know, Brittany, that you actually needed to go. Usually I throw this open for questions, and I would like to give people a quick chance to ask some questions, either in the comments on Google Plus or through Twitter with the hashtag CQX #Hangout.